Hello everyone, myself Azmir Arun Kumar.
I am Ayushi Meena.
Welcome to our experiment on the frequency response of sensor. In this video, we will analyze the response of piezoelectronics and sensor. A photodiode as a part of our ES 116 assignment.
We will explain the setup, demonstrate the procedure, demonstrate the results, and discuss the key takeaways, including resonant frequency, quality factor, and 3 dB cutoff frequency. So let's go ahead.
Azmir Arun Kumar. Today I am going to explain the magnitude response and phase response due to the frequency changes. This is our setup. This is the speaker. This is the signal generator. This is this oscilloscope. We are taking the input from the signal generator to the speaker. The speaker is connected to the oscilloscope. The speaker is invalid to the piezoelectronics. You can see we are doing the piezoelectronic substance is going to vibrate the same frequency and going to the same output from the signal. For to this oscilloscope, we are the same input which we are giving to the speaker, some same signal going to the oscilloscope.
Right now I am going to explain the circuit connection for task 2.
Here, I connected the signal generator to the LED and I also connected it to the oscilloscope so we can get the waveform of the input. Now, here I placed the photodiode in front of LED and I provided 5 volt DC source using Arduino. And I also connected the oscilloscope across the time ohm resistor to get the output waveform. Here, in channel 1 I connected the input source and in channel 2 I connected the output source. Here, right now the frequency is 1.5 kilohertz. If I change it to 2 kilohertz, here I have changed it to 2 kilohertz, we can see the corresponding change in the waveform in the oscilloscope. Here we can see the V peak to peak value of C1, peak to peak value of C2, the phase difference and the frequency.
This is our second experiment, and here is the graph between magnitude, response and frequency, and here you can see that it is decreasing the graph. Here we can see that our maximum gain is obtained at 3100 Hz frequency, and the second graph is phase response. Second graph is between phase response and frequency, and our graph obtained is decreasing the graph. And the third one is, and here is the FFT for the F0, which is our frequency at which our maximum gain is obtained.
Frequency column, the C1 as an input column, C2 as an output column, the phase difference, the gain, the magnitude which is 20 log phase difference. Okay, let's do it again. So now I'm going to explain the So now I'm going to explain the results that we obtain in task 1. We take the readings in the USB from digital oscilloscope as well as we take the readings in the Excel sheet. Here you could see the frequency column, the C1 as an input column, C2 as an output column, the phase difference, the ratio, the magnitude which is 20 log gain, and here with the help of Excel we plot the phase response as well as the magnitude response. Now I hope so. So now I'm going to explain the graphs. So here this is the magnitude response which is plotted between magnitude in decibel and the frequency in hertz. Here we can see the peaks And these are the resonant frequencies. Resonant frequencies are the frequencies at which the piezoelectric sensor vibrates with the greatest amplitude. Now, thoda sa- now we are going to talk about the quality factor. Quality factor can be calculated using frequency and the bandwidth. Bandwidth can be calculated if we move around 3 dB change in the magnitude around resonant frequency. So quality factor is basically the sharpness of a resonant frequency. Now here we can see the resonant frequencies that we obtain are 400, 700, 1000, 1300, 1500, and these. And the respective quality factors are these. We can see that somewhere around 24 hertz, we obtain the highest quality factor, that is 12. And the average quality factor is 2.75. 2.75. Here we can see the peak is around 2400 to 1. पहले के सारे cut करना. 3, 2, 1. Now let's talk about the phase response. It is plotted between phase in degrees versus the frequency in hertz. We can see it's more or less likely an increasing graph. And there is a sudden and a very significant change can be seen around 6000 hertz, where the phase changes from positive to the negative.